Hello everyone. In this playlist I have decided to share whatever I learn, okay? My random learning journey. Whatever I learn I will share, and I will try to not to edit these videos. So if you get some noise and sometimes maybe if you get bored, then I'm sorry for that, okay? So I will share everything with you guys. If you just don't like it, or if you think you need to pause the video, or you need to go forward, you can just do it, okay? You don't have to listen to all my words, right? So here you see I've asked ChatGPT, if I learn and study about all the files of C and their uses, will it be similar to the file system of other languages, okay? I know that there will be some similarities, okay, but I wanted to know from ChatGPT, right? It's a great question. If you study all the standard C header files like stdio, stdio.h, stdlib.h, these etc., okay, and their functions, you will get a solid understanding of how C handles input, output, memory, string operations, and more. But about file system between languages, each programming language has its own standard libraries and way to handle files and files input, output. The concepts are often similar, okay, like opening, reading, writing, and closing files, but the syntax and APIs differ, okay? I don't have to explain this. I'm just showing these with you guys. If I need to explain somewhere, or if I think I need to explain it, you will not understand, then I will try, okay? For example, in C you use functions like fopen, fread, fwrite, and fclose from stdio.h. In Python you use open, and file objects have methods like read, write, close. In Java you use classes like file reader, file writer, buffer reader, etc. So if you understand file handling in C, you will learn the fundamental ideas of the file system and file manipulation, which will help you quickly grasp similar concepts in other languages, okay? So that means, guys, this will be a great help for us if we just can analyze the file system of C. And if we can sometimes we see, guys, when a developer or engineer shows us some works or maybe a project, okay, so they just randomly call functions and they explain everything, but if we don't know how many functions are there, how many files are there, or everything, then we will feel like we are in a sea, we are in an ocean. We don't know actually what's happening. So if we have a clear idea, then we can understand that from that file, or from that from this place we took a function and it's working in this way. If we could take some other functions, then this could this would behave in some other way. So we need a clear understanding, guys, right? So if you understand file handling in C, you will learn the fundamental ideas of file systems and file manipulation, which will help you quickly grasp similar concepts, okay? Summary, knowing C files, and okay, so I hope you understand, guys. We don't have to how many files in C, right? I asked when you ask how many files in C, I'm guessing you mean how many standard header files. The files you include exist in the so we know that we include files like hashtag include, okay? The number of standard header files in C depends on the standard version, C standard version, like C89, C99, C11, C18, but generally there are around 20 to 30 main standard header files, okay? So I hope you can guess what these are. These are the years, okay? So in C89 there were some files. In C99, I mean in the year 1999 it was updated, and it was updated again in 2011 and 2018, right? Okay, some common standard header files in C include stdio.h, we know that, like this one, okay? stdlib.h, general utilities, memory allocation, process control, string.h, string handling functions, math.h. So these are the functions we have in C. Here is the list of main standard header files in modern C. Okay, so how many files in here? 1 2 3 4 5 6 7 8 9 10 main standard header files in list of main standard header files in modern C. sr.h, ct, ctype.h. So these are the files we have, 19 files here. So totally we can say around 30, right? We have some these files also. So we will just we will just see how many things are inside these files and everything, right? So you can think of roughly 20 to 20. Okay, if you want anyway, and then I asked, I will learn by one. Okay, so what are in stdio.h. So I'm asking what's inside this file, right? These were our main these were our first file of C, this one. So let's say what's inside this file. Awesome learning header files one by one is greater plan. Let's talk about stdio.h. stdio is standard for input output. This header file contains functions to handle input and output operators in C. What is inside? Okay, so stdio.h, it provides functions to input output with the console. Okay, so these are the functions we have: printf, scanf, get char, put char, gets, puts. Okay, these are the function we have. And file handling functions: f open, f close, f read write, f gets, f puts. Okay, other utilities: remove, rename, temp file, temp name, num. These are the things we have, right? So example of basic use, you see here printf is this one, hello world. If we see here, okay, if we just copy this and if we see the output, right? So it says hello world, enter your name. So if I give my name, so hello Sadiq. So how is this happening? We see this is the printf function. So because of this line we are getting this hello world. Character name 50, that means it's an array and it will it's a character type. Its type is character type. It will store characters, and there will be 50 characters can be included in this file, right? So enter your name. Okay, so scanf %49s name. Okay, so I will explain why this character %49 now, and then hello, and then %s, that means it will print a string, and you know what's happening, right? Why is this important? Because almost every C program that interacts with users or a file needs it is the foundation of input output operations. Would you like me to give you example of specific functions from stdio.h, or explain how file handling works step by step next? Okay, so show me the use of these are the functions I want to know about. Okay, so ChatGPT gives us these things: age 25, float height 5.9. I hope you understand what float type is, everything. So these are the easy things, guys. Okay, scanf will take input from us. %d mean integer input. Okay, get char, read a single character from the input. So if we just copy these and run, you see enter a character. So if you just put a, then you pressed a. So how is this happening, guys? We declared a character type of variable and printf enter character, and then ch in this variable we are assigning this function. So this function will take as input from us, right? In character type of input from us. So and then the result is stored in the ch variable, and the ch variable is being printed again. So I hope you get this system, guys. Okay. Put care. Okay. So if you see the put, okay, what this put care is doing. If we run this, so you see we're doing character types of variable again here, and we are assigning a in this variable, and put care is getting this ch. Okay, so this prints a and a new line, right? So we will see what's this put care doing. Put care is print a single character to the output. So to print a single character like this a, right? So to put a single character we can use this put care, and get care is for read a single character from the input. Okay, get care and put care is two different things. Get care is taking single character input, put care is printing, right, single character. Gets unsafe. Gets is a function. This is unsafe, and it's suggested that we have to avoid. And fgets read a line of text. Unsafe gets example. Okay, so we don't use gets because this is unsafe, right? So if we copy this again, and if we run here, okay, dangerous not okay. So we see here character types of variables str, and we have 50. We can take 50 characters here. Enter a string and then get string. Dangerous not okay, and you entered. So it's saying basically it's saying not to use. Okay, so if we could use we could give input here, right? Maybe in this compiler it's not allowing us, no problem. So fgets is the safe option. So if we just copy this, enter a string, character 50, print enter a string. So if you put enter a string, right? So like as you entered Sadiq, right? So fgets takes these parameters, guys. str, that means this string will be passed here. fgets is taking input too, right? So whatever you give input, this is being stored in this str, right? Size of str, it's automatically calculate the size. Okay, so if you give this word 1 2 3 4 5, so it's measures the length as well, and standard in. So this is also a parameter, and you entered str, right? So you may anyway print a string followed by a new line. Puts print a string followed by a new line. Okay, so let's see what happens. Okay, so that means this is creating a new line too, right? Whatever you write after this, everything will be printed, or things will work from the next line. Okay, okay, so file handling functions. So file handling is would be little bit hard for us to visualize or get output from here, because we are not making any we're not making any software here, or we're not making any project, so there will be no file, but we can just guess what's happening. Let's have a read. Give it a read. Sure. Here's example, a simple clear example demonstration, the use of each of these file handling functions in C with explanation. So file handling functions in C example, like these things include stdio.h, stdlib.h. So these are the thing in okay. So everything is given in this same file. So I asked that give me a separate example of each. Okay, so it's giving me separate example of each. Let's just copy and try to have idea what's happening. So you see error opening file, because we are not making any project here. So these are the for project, like if we make any project and that project has like test.txt is a file, right? So then maybe it would open that file, but in our case we are not making any, but we can guess open file for writing. If file is null, file equals null, there is no file, then error opening file, return 1, printf, otherwise printf file opened successfully. Okay, so f close file. So f open is basically opening files for us when we make project or everything, right? So guys, these videos will be long and sometimes maybe I will be stopped because in my environment many things can happen. So and I will not edit this, because editing these types of files would be will take time, and the sound quality will not be so good because guys because I am just recording from OBS and my laptop is detecting the file. I am not using extra good microphone, right? read binary data from a file, data.bin we open binary file for reading. Guys, open wait for a minute for me, I'm coming back. I'm just coming back. Okay, maybe I will take 5 minutes. Okay guys, then we have f write binary data to file, and then f gets read a line from a file, right? So this is the thing. F puts write a string to a file, f print format output to a file, f scan formatted output from a file, fof check if end of file is reached. So these are the thing we have. So maybe later we will learn about this. Okay, other utilities: remove, rename temp file. Okay, so I asked show me their use separately. Okay, so here you see for removing this, for removing a file we have this. So these are the thing we have to just understand now, because we are not making project. So maybe later we will see this. Okay, temp file create a temporary file. Okay, temp name. Okay, what's inside stdlib.h, right? What's inside this file? It's a great choice. stdlib.h is one of the most important standard C header files. What's inside stdlib.h? This header provides general purpose utility functions that cover a wide range of tasks such as memory management, malloc, allocates memory dynamically, calloc, allocates memory. So these are the functions we have: memory management, process control, conversions, sorting and searching, random numbers, other utilities. So these are really important, guys. Okay, stdlib. So these files are really important for us, and I saw many use of them. Okay, so dynamic memory allocation, like so if we just take this copy and okay, so we see this output, guys, right? So we have to discuss about the code, right? So integer array, okay, so this is a pointer. It is a pointer to an integer, right? What it's doing here, it's making space. This malloc function is making space for 5 elements, right? You see 0, 10, 20, 1, 2, 3, 4, 5, making space for 5 elements, and the address of first element, address of this first element is being stored in this array. Okay, in this pointer, right? So this pointer is pointing to the first element, I mean first element's address, and this is how the whole array is being stored in this array pointer. This array is pointing to that, right? So if array equals null, then memory allocation failed, right? And now everything is being printed. I equals 0, I is less than 5, I plus plus. So array I. Okay, that means if you want, we can just visualize, guys, this. Okay, so do you think we need it? Okay, let's just take some time and visualize this. Let's make a file here. Okay, so if you want to visualize this one, okay, so this line is creating a like one, two, three, four, five, like this. Okay, so if this position has an address like 0x01, and this has an address like OX02, OXO 1, 2, 3, 4. Let's say we have 4 here, 4 bytes, as it's integer types of variable is So this is how it is going, right? 5 position for 5 is being created here, right? So if we just take a fast iteration, do one thing, let's keep it, right? If we just first iteration, then I equals 0 and 0 is less than 5, right? So array 0 means, guys, if you put array 0, so i's position is 0, array 0, so 0 into if you say zeros, there is no value in this array, right? So in this 0 position we have 0 into 10, that means, guys, it would be 0 here, and printf, now it's being printf array I, that means array 0, this 0 is being printed, this is the value. Don't think that this 0 is and this 0 is same. I's position, okay, so this first element's position is 0, that is the thing. So I hope you guys understand these things. And second iteration, see 1 here, so let's increase here, okay, so I will be increased 1 by 1, so from 0 it's been 1 now, so we are not changing this initialization position. We will have a look here, okay. There is some specific reason, but I'm not going to explain this here, but you just visualize in this way, okay. So i's position is 1 into 10, that means 10, guys. So in the first position, we will put 10, okay. This one is 0th position, this one is first position. We need to keep in mind this, right? And in the third, this will continue, guys, until it's less than 5, okay. So and then free array will be freed, memory allocation will, this is how it works. So malloc is creating space for our element, so we see the use of malloc, right? String to integer conversion, okay. So let's see what's happening. String to integer conversion, dynamic memory allocation. Conversions, okay, so it's showing us another function here. Let's see the output of this. So converted number is 1 2 3 4 5, okay. So what's the use of this? String to integer, okay, converted number, okay. So this string, yes, these are numbers 1 2 3 4 5. We know that these are numbers, but when we put inside the string, like this double quotation, right, so it's now string, so this string is being converted into number from by this file, by this function atoi. Anyway, and then we have asked, would you like me to provide examples of explanation for a specific function inside stdlib.h? Show me their use separately. I'm going to ask, give me the separate use. Malloc allocates memory dynamically, so integer, main integer, pointer tier. So you see here allocate memory for 5 integers, okay. So memory for 5 integers is being created here, and this pointer is pointing to the first element of this array, okay. So if we just show you here, okay, so this array pointer is pointing to the address of first element, you understand? And by pointing to this first element, whole array is being being pointed by this, you understand? So ptr, okay, allocates memory 5 integer. If ptr equals null, then okay, assign values and print. So these are the same thing we saw here. Calloc allocates memory for any array and initialize it to 0, okay. So that means, guys, malloc and calloc is the same, but calloc initialize values in 0, in every address. 0 value will be stored, right? If we copy these and you see all the values are 0, so we can update later, but realloc, okay, resize previously allocated memory, it resizes, okay. So let's see. You see here ptr malloc 3 size of integer, allocate memory for 3 integers, and memory allocation failed. Okay, if it's null, assign initial values. So initial value is I0 in the 0 position would be 0 plus 1, right? So first, in the first position output is 1, and the second position 2, 3. This is how. Assign initial values, resize memory to hold 5 integers. Okay, so you see here malloc is giving us space for 3 3 integer values, right? So by this for loop we could get only three numbers, 1, 2 and 3, right? But finally we are using realloc, okay, realloc. So resize memory to hold 5 integers. So now we are giving space for 5 integers, okay. So now we are assigning values, and here I starts from 3, okay, because we already have 3 elements. So I will start from 3, and 2 values will be printed from this for loop, okay. Print all values, and all the values is being printed here, and then ptr is being we are freeing the ptr, okay. I hope you understand, guys. Not so difficult, right? Free allocated memory. So free is also a function. Okay, so 4 integers space is allocated here, and then if ptr equals null, memory allocation failed. So anyway, use memory assign values. I equals 0, I is less than 4, okay, I plus plus ptr I with I into 2. So that means, guys, 0 into 2, first is 0, then I will increase 1 into 2, that will be 2, and then 2 into 2, 4, 3 into 2, 6. This is how it will increase, guys, okay. So now free ptr, we are freeing memory, and we are not printing anything, right? There is no print statement here. So ptr is null. Good practice to avoid dangling pointers. After free, ptr points to deallocated memory, avoid using it, okay. Okay, so after freeing, after free, ptr is still pointing to deallocated memory. So we need to just, if we put ptr equals null, then it would be good. This is saying it's good practice, right? So we have process control. All right, here are some separate examples. Process control: exit, terminate program execution, okay. So you see here stdio.h, stdlib.h, program starting, printf program starting, something goes wrong. If 1, printf error occurred, existing program exist 1, exist immediately with status 1, printf this will never be printed. Anyway, anyway, let's see. Program starting, and if something goes wrong, if one error occurred, existing program exist one, exit immediately with status 1 error. This will never be printed. Anyway guys, so you see this line is not being printed. Okay, this is because we are existing here. So terminate program execution. Okay, at exit register functions to be called at program exit. Register functions. Okay, there are some more files. Okay, okay, let's see what's happening here. If we just copy these and paste in here. Main program running, cleanup function 2. Okay, cleanup function 1 is okay, main program running. So let's see, at exit cleanup 1, this is the first program, this is the first function. So and then this is the 2. So first printf is main program running. So this is the thing will be printed first, and okay, so I need to get explanation for this. I will ask, can you explain this? Yes, let's walk through it step by step so it's crystal clear what the program does. You've done 2 functions, they just print a message, you then register with them. Okay, it tells you when the program when this program ends. Normally the exit run this function before actually terminating. Important behavior: at exit runs register function is reverse order of registration. That means you registered cleanup first, you registered clean up to second, at program exit cleanup 2 runs first, then clear. This means guys is it's working in reverse order. Okay, flow of execution: main starts at exit clear store in this store cleanup 1 in the list, store cleanup 2 in the list. Okay, printf the main program prints the message before the program actually quits. See, runtime checks if any at exit functions are registered, runs them in last registered first order. Okay, last in first out. Okay, this is the thing happening here. Okay, so we had another function rest, we need to learn about that too. System. Okay guys, execute system commands. Okay, so printf listing current directory content, system on Linux. Okay, system print creating a folder. So let's see, these are the files. Maybe we will hardly needed maybe, but Okay, anyway, we will stop this video here. See you in next video, guys. Okay, so I will share everything I learned. Doesn't matter how many hours I study. This is my random learning path, and I'm just showing you guys whatever I'm learning.